Moving on, I'd like to introduce our first keynote speaker for Nanog 87. We're delighted to have here with us Elad Nafshi, Executive Vice President and Chief Network Officer at Comcast. With his talk, "The Future is Now, Delivering Next Generation Brilliant Network," Elad will share how 10G network technologies are evolving connected experiences in real time, even as they continue to get smarter, faster, more reliable, and secure for future generations. This is Elad's first time at Nanog, so welcome to the stage, Elad.
Thank you so much. Good morning, everyone. Can you hear me? Oh, there you go. Now you can hear me. Well, this has already been a very educational moment for me. First of all, it's so great to see so many of you. It's great to have these conferences again, isn't it? It's fantastic. You could stare at these screens all day long, but when you get to experience it and interact and talk to so many people, it's fantastic. It's been educational for me because I've learned that Atlanta's one of their origin names is Terminus, and if you're a Walking Dead fan, you would remember that episode. It was actually shot like 15 minutes away, so that was educational for me. And then, just to add to Future's comment, it was also the first all-female Navy pilot flyover over the Super Bowl yesterday. So, lots of reason to celebrate the Super Bowl yesterday, except if you're an Eagles fan like myself, which there's not a lot of reasons to celebrate this morning. But you know what? I got back from watching a game with my buddy of mine at like 12. I got on a flight. I got up and got to catch the flight at 3 a.m. this morning. So if I fall off the stage this morning, please excuse me. There's mitigating factors here. It's been a long night and a very depressing one at that. Let's get going. So what is the Brilliant Network and how is Comcast working to deliver the future network and how it's all coming together right now? And I'll start, if you will, in case this remote does not like me. In case you missed it during the third quarter of yesterday's game, it wasn't Philadelphia's best quarter. So that is kind of unfortunate. But in case you missed it, I wanted to share it because it really sets the stage for everything that I will talk about today. And it was made by our finest marketing people. So let's start with that.
The Eagle has landed. That's one small step for man.
Hey, what's up?
One giant. Houston, we have a situation. How did you get here?
Your character's in our video game.
Video game?
Yeah, it's what we can do with the Xfinity 10G network.
Basically the greatest achievement since the moon landing.
Think they're talking about us? I know.
You can play from anywhere now.
Yeah, I'm in the basement. I'm at the dentist.
Check this out. It's super smooth, even when everyone's online.
Oh, can I try that?
You're in the game?
What the heck is that?
Those are the bad guys.
Are they friendly?
Nope.
Okay, here's the plan. On the ship, there's some wire cutters, some tubing, and rubber bands. Now, with our know-how and some elbow grease and a little bit of luck,
You're probably going to want to start running.
The next generation 10G network, only from Xfinity, one giant leap for mankind.
So that's the marketing speak of what the technology will enable. And let's just, summarize what we heard. First of all is obviously speed. Much faster, more symmetrical, more reliable, lower latency, enabling more concurrent speed and enabling it everywhere. And that, if I had to put in a nutshell, is the essence of the network that we're building and are working so hard to deploy everywhere. So how does that work? It starts by work that we've been kicking off for about 5 years now around virtualizing our access network. So what does virtualizing the access network mean? It's really around 4 key pillars. Okay? The first one is, if you look at kind of traditional cable networks, we have relied on proprietary, vendor-based, typically book-ended solutions in order to deliver the high-speed data network. right? The CMTS, or the Cable Modem Termination System, has been with us ever since DOCSIS, data over coaxial cable spec, came out, and has really defined how high-speed data is being delivered for the past 20 plus years. The challenge with the technology, although it's very robust and obviously it's very scalable, is that it relies on, at this point, antiquated analog technology, delivering via analog optics to analog nodes, and it's an appliance-based, right? And so when you look at the cycles of innovation on an appliance-based hardware, right, you're typically looking at 6, 7, 8 years, right, where our competitors are web scalers. They innovate at Moore's law speed, right? Every server that I buy today is going to be twice as capable at the same price 2 years from now, and so on and so forth. And so the first thing that we've done is we virtualized and separated between the hardware and the software. We control the software. The hardware is Intel-based edge compute, nothing custom. And what we're able to do is, and we're actually in the process of launching a third generation of virtualized hardware, doubling the amount of capacity every time, just relying on the latest Skylake chipsets from Intel. Okay, so that's number one. The second piece is, and I kind of alluded to it earlier around the analog optics, we're able to graduate and transition into digital optics, both coherent and pluggables, which enable us to bring the digital signal fidelity all the way down to within hundreds of feet from the home to a new generation of digital nodes. That means that the overall service reliability and the actual service quality is extended all the way down to nearly the home, and in a much more robust, more reliable way. The third piece is that web infrastructure does not have kind of the traditional visibility that you would normally have in an appliance-based architecture. What does that mean? There's no SNMP, none. It's all streaming telemetry. Why is that important? Well, I always use this example. I have 4 boys, okay? 2 of them are off in college, 2 of them are younger. And when COVID hit, the older ones begrudgingly came back home because they closed the school, right? And we all learned how to live together again as a family, right? And I was working from home, and in those rare occasions that the internet was down, within 15 seconds of the internet being down, I would have 1.5 kids in my home office letting me know that the internet is down, right? Such harm, they will never recover from it, but that's the burden that we have as service operators now. It's no longer okay to know what happened to the customer half an hour ago because that's the SME people. We need to know about it immediately. And then it plugs into the fourth one, which is we want to drive AI and machine learning into everything that we have. Why? Because it could react faster, it could resolve faster, and it could ultimately drive a much better customer experience, which is what we're about. Okay? So with this virtualized architecture, we started to deploy across our footprint. And as of today, we have almost 80,000 of those digital nodes deployed across our network. That number is growing by over 1,500 per week as we're working very hard to upgrade our network across the board. And we've already upgraded over 10 million customer homes with this new technology across our footprint. So this is not PowerPoint. This is real scalable technology that is servicing millions of customers already and will be rolled everywhere across our network over the next several years. So what does it look like? How does it all come together? Yes, it's going to be fast, and we're over this architecture going to be able to deliver multiple gigabit symmetrical services to all of our customers, and we'll talk about how we're going to do that. Enhanced reliability is really going to come about by relying on new cutting-edge cloud-based platforms that are also built with real-time visibility, and with real-time visibility comes inherent reliability, and I'll show you how that comes together. Low latency is going to be in the middle of all of that, and you're going to see that too, and then it's available to everyone. Unlike some of our competitors that dig the right side of the street or the left side of the street or the better side of town, our technology will enable all of that to each and every one of our 60+ million homes across the US. So that's great. How do we deliver the multiple gigabit symmetrical services? Well, already today, we started delivering multiple gig on the download side, and this is the technology and speeds that are available to those 10 million customer homes, reliant on the latest and greatest data over coaxial cable implementation called DOCSIS 3.1, okay? And we're doing two things here. Number one is we're expanding the amount of traffic that we're able to service with DOCSIS 3.1, and that's how we're able to deliver the 2 gig down. And for the very first time, we launched DOCSIS 3.1 on the upstream, and that's how we're able to deliver a lot greater speeds on the upstream as well, increasing the upstream speeds anywhere between 7 and 10 folds from what was a traditional cable delivery with the previous format of DOCSIS 3.0. Okay, that's good. That's something that, again, is already available to millions of subscribers. But now comes the future. The next iteration of the DOCSIS spec, called DOCSIS 4.0, enables us to deliver the multiple gigabit symmetrical services by relying on full duplex technology that now is able to reutilize the same frequencies and deliver upstream and downstream right on top of each other much more efficiently, driving these type of speeds. Now, what you see here is just the beginning. We've already demonstrated on a live plant almost 9 gig down and 5 gig up on a real production network, and with further service improvements in optimization, we're going to be able to go even faster than that. And that's the technology that powers the 10G network that you saw the commercial of. Okay? Now, the advantage of this architecture is that, again, it's easily upgradable across our footprint by software download to the virtualized architecture and an electronic upgrade to the digital platforms, the nodes and the amplifiers that we're installing on our network. And so that's how we're able to get with these type of speeds everywhere across our footprint. We talked about the enhanced reliability, and allow me to kind of reminisce. I started talking about COVID. Friday the 13th, March 13th, 2000, right? We all went home. There was this thing called COVID. It just hit. It started on the West Coast 2 weeks earlier, and it made its way over to the East Coast. And on Friday, we all went home. And, there's a lot of network folks here, but I don't know anyone who's built their network with the anticipation of a global pandemic that will force all of us to jump on video communication applications like Zoom or Teams or WebEx and spend 2 years on them without leaving, right? And so what happened immediately during those first 2 weeks was we saw about 3 years worth of capacity growth in 2 weeks. Okay, well, you could deploy more capacity, and we have. This is at a time where, our technicians really couldn't go anywhere, and, it was hard to go into areas, and it was really difficult. And at the end of the day, to add capacity, you can only add so much, right? So what we have to do is rely on innovation, and innovation comes with software. And this is really where this concept of this platform we call Comcast Octave. And what Octave does is, who here is a Comcast customer? Excellent. So I will pick on you right here in front. And, I'm a Comcast customer in Philadelphia. You're a Comcast customer where? Maine, okay, excellent. And even though we're all on the same network, the network conditions that lead to your home versus the network conditions that lead to my home are different. I just happen to live right behind a cell tower that's right by a high school. That's good. And, if I don't have every connector tightened up in my home, I'm at risk of having LTE, transient interferences, et cetera, which may impair my services versus your home might be just fine. And so what Octave does is it looks at 4,000 different data points across our network, across 50 million devices, and makes a decision every 20 minutes on what is the maximum modulation that we could deliver down to your home, meaning the efficiency of the bit delivery down to your home versus my home, and make a decision on that in real time. And make those decisions millions of times every day. And by running this AI and ML platform, which we rushed to production in the beginning of COVID, we were able to increase our capacity by over 40% by sheer software innovation at the time that we needed it the most. That's how real-time visibility increases not only reliability, but also real-world performance challenges. And so when you take a step back and think about this, from running the network at a national level or at a regional level, the market level, with the Octave platform, which was really the first one that we've launched, we're now able to optimize the service delivery down to the individual customers' homes and do that in real time and do that without any customers even knowing that those tweaks and changes on the back end were done throughout the day, as I was saying, millions of times a day. So how does that now extend into fiber delivery? We have hundreds of thousands of miles of fiber. Anyone knows what this is? Yeah, that's hours of downtime. That's what it is, right? Because notice it pinched all fibers on the strand, and I actually took this photo in Sacramento. And now, imagine, if you will, you're the technician that at 2 a.m. need to go find this, a dark cable at night when it's raining in Florida, or where it's Super Bowl Eve in Philadelphia last night. We had one of those. Okay? And so the question is, well, how do you do that? Well, with current technology, you need to have a technician go to the head end, right? Shoot an OTDR, which basically measures, distance of where the breakage point is, and then go to the other end and measure, you get the picture. Hours. Is there a better way to do this? And this is, again, where Comcast Innovation comes in, and we've built a new device called the XMFR. We're better engineers than marketers. Our marketers make videos. We make engineering. And what the XMFR does is, as we roll out this network upgrade, we're installing real-time monitoring capabilities across all of our access fiber, which enables us to do two things. Number one, monitor it in real time, and these are overactive fibers, right? So it doesn't require a sidecar fiber in order to do the monitoring, and it comes with built-in OTDR capabilities already in the box. And so within 120 seconds of any fiber impairments across our footprint, we're able to pinpoint, first identify, pinpoint exactly where the fiber cut is, and then auto-dispatch the fiber restoration crews to that location. No human needs to go and look at and try and troubleshoot that fiber is cut. We know that for a fact. We know that in real time, and now we're able to bring action to it by resolving the fiber cuts in real time. That's part of how we're able to put real-time telemetry into the reliability. The next one is, okay, well, we still have a lot of coaxial cable, and how you're able to pinpoint egress points, right? When you send out technicians today, it's where in a cascade the egress points are, right? And so you have to go down in order to figure out, because egress flows upstream, and it could be hours and hours and hours to try and pinpoint exactly where the point of impairments are. And in addition to that, you never quite know whether the problem is inside the home or outside of the home, right? Is it just a matter of tightening up connectors in a home, or is it more of a systemic problem? With the real-time telemetry overlaid on top of a topology database, which again is technology that is now finally coming to maturity, we're able to pinpoint exactly where the egress point is with probability. It'll never be 100%, But hey, if we dispatch a technician to that particular amp on the network, there's an 80% chance that that's where the source is. But in addition to that, by detecting pattern detection on the line itself, again with real-time telemetry, we're also able to pinpoint what kind of interference is it. Is it water in a coaxial cable, which is a draw problem? Is it a resonant peak, which is an amplifier problem, and so on and so forth. And the data sciences teams that are analyzing these are getting better and better at not only pinpointing where the problems are, but what the problems are before we dispatch the technicians so they know exactly what they need to fix when they get there. Now, these are not science fiction's applications. These applications are already action on in the field, and this is just the beginning as you sit on these petabytes of real-time data bits. How do you put these type of algorithms to use in order to enhance our reliability, again, all in real time? I talked about latency, and as a gamer, this is near and dear to my heart now. I mentioned I have 4 kids, I have 4 boys, okay? And in parenthood, there's this moment where your kid is better than you in online gaming, okay? It is a bittersweet moment, right? And on one hand, you're like, okay, I'm proud of you, boy. And the other hand is, how in the world, if you're playing Fortnite, right, can you jump, do a 360, and with a sniper rifle hit, dead on? I have not mastered that yet, but they have. So now I can always blame latency for it. And what you're seeing here is a video of a hackathon that we've done in Philadelphia over the summer. And on the left-hand side, you see kind of a traditional internet delivery. And the red bars that you're starting to see accumulating is that connection was playing Netflix at the same time. And so this is what's working latency in real time means, right? Bits starting to accumulate, latency, working latency starting to accumulate. On the right-hand side, you see DOCSIS low latency, which is part of the 10G experience. And you see absolutely no latency building up, and that's with content labeling, enabling us sub 10 milliseconds of working latency across our footprint as part of our 10G network. Everywhere, not point location. Now, I talked about everyone, and I met a couple of folks already here today that are quote-unquote fiber guys, and that's at the end of the day, does a customer care what dark cable connects their home, right? So I've asked one of our vendors, CommScope, who make fiber and they make coaxial cable, to send me pictures of the 2 reels of the cables. One of these is fiber, one of them is coax. Can you tell me which one's which? Do you think the customers care? They're paying us for services, they're paying us for speed, they're paying us for reliability, they're paying us to make sure that whenever they need to get it online, their products will work, right? So what difference does a wire mean? Now, traditionally, again, when you're in an appliance-based network, it does matter, because you have an OLT for fiber and you have a CMTS for coax. But in a virtualized architecture world, this is the Comcast innovation again coming in. And so what you're seeing here is one of our digital nodes. That digital node now has 2 different compute units. The one on the left delivers DOCSIS 4.0, and it is able to deliver multiple gigabit symmetrical services over the same virtualized architecture with digital optics that I mentioned earlier. And do that to the coaxial homes connected out of this node. And on the right-hand side, you see a different compute unit, which is effectively a remote OLT with tidbit pluggables, and we're able to deliver multiple gigabit symmetrical services to homes that are connected with fiber off of the same digital node, and be able to do that completely transparently and completely interchangeably. The operations is the same, the real-time telemetry is the same, it all feeds off the same virtualized architecture, and all of that completely seamlessly from a platform standpoint. And that is the key differentiator of the brilliant network, right? We abstract the wire, it doesn't matter. The services will be the same, the reliability will be the same, and the scalability will enable us to deliver the right solution to the right customer. We don't need to dig up streets. We don't need to tear up front lawns. We don't need to make you stay home for 8 hours for an installation. Unless you require a certain service, whether you're a business or commercial customer, we're able to make the right wire location to the right customer with complete optionality and complete technology invisibility. It doesn't matter. Now, this is great, but how do you carry multiple gigabit symmetrical services over a coaxial network? That can't be done, right? And so what you're seeing here is the first DOCSIS 4.0 FTX amplifier. And this is kind of the holy grail in being able to deliver the multiple gigabit symmetrical over coaxial cable. And this is not just PowerPoint. As you can see, it's a real device that we're working very hard to bring to market and be able to launch broadly. This device will enable us to get those type of services across our entire network. So going back to the foundations, multi-gigabit symmetrical speeds, enhanced reliability, unprecedented visibility to everything. And I talked about the visibility from a technician standpoint, from a technical standpoint, right? How do we resolve things? But picture, if you will, taking all of that data and now putting it at the services of our customers. We know there's a problem. Don't call us. We got it. There's a fiber cut. The ETA is 4 hours, and we'll continue to update you as we're working to resolve this. And this is, again, not science fiction. This is something that we've already deploying across our network, reliant on the real-time visibility. Low latency. I showed the hackathon that we showed in the summer, and I can tell you that some of us might already actually have it in their homes. I still am losing to my kids, but I'm old. What are you going to do? And available to everyone, truly making this technology ubiquitous across our footprint, which is something that we have always done and are very proud of. I talked about the multiple gigabit symmetrical services and how that comes together. It's really exciting to kind of see how it's coming together, but at the end of the day, it all depends on how we're delivering those network capabilities in home, right? Service or network is only as good as being able to actually have the devices to deliver it to our customers. And this really relies on a range of award-winning devices that starts with Wi-Fi 6E gateways that deliver the absolute best in-home Wi-Fi experience. In order to extend the Wi-Fi capabilities, you really need pods to be able to spread in a mesh network environment across the home to make sure that every home can experience these services. And that's with our X5 pods. And then all that big pipe and all the great speeds that you have, it's we had the cyber person introduce all the evils that exist out there. And if you're dealing with network security, it is a daily and never-ending battle. But at the end of the day, you want to make sure that that is seamless to the customers. You want to make sure that we're securing them always. And that's with our advanced security that is available on each and every one of our gateways, built in and providing the absolute best in-home security across the board. And if you look at the design of these, and I obviously my home is benefiting from each and every one of those, whether it's the IP video devices on the left-hand side, or the gateway, which is the white tower in the middle, or the pods, which you see right next to it, or each and every one of the other connected devices that you have at home. All of it benefits from the 10G network that we're so excited to be deploying across the board. So how we got here, it's been busy. I'm not gonna lie, it's been really busy. And just to put that in perspective, it hasn't even been 2 years ago when the very first DOCSIS 4.0 chipset became available. April of 2021 is when we got the very first pre-production SOC showing how PowerPoint and then a Cable Labs DOCSIS 4.0 spec becomes real-life technology, which is really exciting, when you see technology turn into actual silicon that you could start to take advantage of. By October of 21, we're actually able to take that and complete the very first end-to-end DOCSIS 4.0 multiple gigabit symmetrical services full delivery on an end-to-end basis, meaning all the way from the virtualized architecture to a modem delivering these bits. And in April, we're able to showcase this working on a real live plant in the Denver market, delivering almost 9 gig down and 5 gigs up. And that is on an end-to-end, meaning over a real live plant, over real optical transport, running off of a real virtualized CMTS in that market. And that was pretty exciting. But you know what was more exciting? Being able to put this in front of the first customer right before the holiday last year. And there's a couple of things that I'm super proud and excited about. One is from spec to a live customer in 18 months. That's pretty exciting. The second one is the very first customer to get these multiple gigabit speeds was a non-for-profit organization called ShareFood, who I just happen to be on the board of. It is the largest hunger relief organization in the greater Philadelphia area. If you saw where that organization operates in the toughest neighborhood in Philadelphia, and that's where we chose to bring a very first multiple gigabit symmetrical service to. And I'm very proud of it. And that's kind of the guiding principle that would guide us towards me standing here today talking about the launch of the 10G network, which we formally announced at the Super Bowl, the third quarter Super Bowl last night. Or it would have been great to cap with an Eagles victory, but that was not to be. But the 10G network sails on and is available to, like I said, 10 million subscribers and growing, subscriber homes and growing. And then our commitment is that by the end of this year, we're going to be able to start launching the multiple gigabit symmetrical services across a footprint, and this technology truly coming together in an end-to-end fashion. This is the 10G network. This is how we're building a brilliant network. I'm super excited to share that the innovation that we've built was actually recognized by the Emmy organization. And a couple of weeks ago, we won a technical Emmy award for the virtualization that we were able to put together and launch nationally. So I'm very proud of the work that the teams have done. And now we need to bring it everywhere. And this is how the next generation connectivity powers next generation innovation and is here now, available to millions of subscribers and even more over the next coming years. So thank you. Thank you for the opportunity to tell our story here today. Thank you.